Welcome to Pepperl+Fuchs Plugged In, where automation professionals can stay in touch with the latest enhancements in sensing, data communication, and control.
Welcome to episode 2 of Pepperl+Fuchs Plugged In. Today I have Nolan with me. Nolan, hello, how are you?
Hi, I'm doing well.
Nolan, we are in the process of releasing, as I was told, a very exciting new product in our LiDAR product family. Can you tell me a little bit more about that, please?
Yes, absolutely. We're excited to be introducing a compact, precise, and accurate 3D LiDAR scanner, which takes in a very large number of samples per second and sends them at high speed over Ethernet to the user. Basically, this four-plane scanner will be available in a more compact package than our famous single-plane R2000. It is built from the same high-quality DNA, but has four planes.
Could you please clarify the R2000 comparison a bit more for us?
Sure. The R2300 uses PRT, or pulse ranging technology, wherein,
Just like the R2000, right? No, I'm sorry to interrupt. That's about the same. Both
yes,
of these use PRT.
yeah, exactly. And so we fire a very short, precise, high energy burst of infrared light and then receive the returning photons with a sophisticated method that can process optical events with very high accuracy to achieve a true time of flight result in the same manner that made our R2000 known for its industry leading performance. It's created from the same design DNA, and we can again offer our renowned precision, noise immunity, and crosstalk protection.
So what you are describing is a precision LiDAR scanner with 4 detection planes. That sounds expensive.
Yes, a great question. That's understandable that it would seem that way. But let me say something about that. Due to what we've learned in our long traditions with the R2000, we've been able to come up with a very efficient design and manufacturing process that allows us to offer the R2300 at a surprising price point, actually.
Oh, okay. Now, R2000 naturally our flagship product comes up time and again. Can you talk a little bit about how the R2300 compares to the R2000 in terms of applications and positioning in the market?
Sure. Um, we're happy, of course, to be able to deliver the high precision and three dimensions of scanning. But let me state it this way. For the highest resolution, longest range navigation, localization, or other LiDAR needs in one plane, we would still recommend various members of the R2000 family. But for users who like similar capability in a more compact device, but with four planes, the R2300 should be a great fit. And another bit of great news, the telemetry, the interface to get the data is very similar. So this should make the client's data processing task a bit simpler or shorter for anybody who's already familiar with the R2000 interface.
Okay, so what does it mean in terms of a learning curve for a programmer? And I'm thinking about a person that has R2000 experience and now wants to also implement an R2300 or vice versa. Someone starting with an R2300 and then needs the functionality and the power of the R2000. What can they expect?
I must say this is definitely some good news on this front. The learning curve is very similar and very easy because anybody who's familiar with the R2000 will find this interface to be quite an effortless addition to the LiDAR tool chest. If I'm designing, say, an AGV or AMR that must have enough visual awareness to not only avoid collisions, but also be able to perform higher functions, such as positioning, dimensioning, or navigation, the R2300 would be foremost in mind when range, cost, and size goals are lower numbers versus the top R2000 models. But to be able to transition from one to the other is very easy because they use the same interface packet types.
No, that's really good news. Can you break that down a bit further and try to summarize 2300 versus R2000?
Yes, the R2300 offers much of the same higher function and precise hardware quality as the R2000, but at a price point that may be more reminiscent of a simple collision avoidance sensor. And we have 4 planes of data.
Okay. Anything else that is exciting and new about the R2300 that our listeners should take away from our conversation?
Yes, it has dual lasers. So one is actually the infrared laser involved in PRT and used for measurement, while the other is a new visible red laser which serves as a pilot. By simply sending a TCP command, you can configure this feature on the fly and turn on these pilot lines for convenient installation, and then turn them off with another command. That same command scheme, by the way, can be used to adjust tons of other properties such as the sweep angle, scan rate, or other parameters.
All right, got it. Okay. Now, we've mentioned the fact that the R2300 is a 4-plane scanner, let's call it a 3D device. Can you tell us a bit what are the real application benefits that users will get from that design?
So, application benefits or use cases, why should people care? Yeah, let's talk a bit about that. The presence of more than one plane is a huge benefit, in particular with AGVs and AMRs, for cliff detection, avoiding drop-offs and holes, and even suspended or hanging objects. For example, imagine an unoccupied forklift which has been left with its forks off the ground a bit. Single plane scanners will miss such hazards, which can be more readily seen when the LiDAR is able to look up and down as well as flat across the work area.
So what you're describing would traditionally be called a collision avoidance sensor. Does that mean the R2300 is not intended to be used in navigation tasks, navigation applications?
Actually, the same sensor being used to avoid trouble can also supply enough situational awareness to navigate around an impeding object instead of calling for help and waiting for manual intervention from a human. Load detection and dimensioning, pallet pocket detection or fork guidance, and docking or charging are also good applications which can be run from the same single R2300. We really expect to find a lot of great projects with this nice compact scanner.
Yeah, sounds like it. So we're running out of time, Nolan. In closing, can you please share with our listeners a 5-word or less a short statement that summarizes what everybody that's listening today should take away from our conversation?
Compact, durable, precise 3D scan.
Compact, durable, precise 3D scanner. Well, again, you guys are great. Another person that matches exactly the demand. 5 words. Excellent. Hey, Nolan, I thank you very much for the conversation. Good luck with introducing the R2000. Introducing the R2000. Oops, that's not what I intended to say. Of course, I'm not talking about the R2000, but rather the R2300. So let's get back into the podcast. To the marketplace, and we'll be talking, well, later. Bye-bye, Nolan.
Thank you, Helga. Bye.
Well, welcome back to segment 2. I have Mike with me, and Mike and I are going to talk about RFID tags. Hello, Mike.
Hello, Helga. How are you?
I'm going okay, thank you. So, Mike, what did you bring us, and why are we talking about RFID tags in the first place?
Okay, so we do have a new ultra high frequency RFID head coming out very soon, and it's going to be great. But I'm going to talk more about that later on in some time. But today, it's important to know that we have a lot of ultra high frequency tags already in our portfolio. Sometimes it's very easy to forget some of the tags that we offer. So today I just brought 3 of them along, and I'd like to just kind of reintroduce them really quick.
Awesome. Now, of course, we should mention that RFID systems are really nothing without the tag. So they're critical components.
That's right. That's absolutely right.
Okay, let's get to the first one.
Okay, well, so the first one here, it's about the size of maybe a matchbook, a little bit bigger. And you can go ahead and just listen really closely. Ready?
Ready? No. Did you whack that tag with a? What did you do there?
I did. Yeah, I whacked it with a hammer. And I'm going to do it again really quick. Yeah. And so
That's
if I
brutal.
take this tag, though, the cool thing is that that thing's going to still read. This tag is tough. It's made to be mounted on metal. It's the IUC 77-F151-M-GBL. And you're right. This tag is it's able to stand up to something that's brutal. So,
and it's a UHF tag, which has decent read range.
well, it has a really good read range too. You're right. Yeah, this tag can be read from a great range. When it first came out, it was great because the way to demo this tag is to literally take it to fairs and allow people to come up and just bang on it with a hammer. And the tag will still read after it. It's fully potted. And what that means, it's as I hold it in my hand, it kind of feels like a hockey puck material. So there's not going to be any steam or any water that is going to get inside of this tag. So, you can either sit here and stomp on it all day with a boot, or you could put it on the side of a rail car that goes through the Amazon. And this tag will survive for years in that environment. So
that's awesome. That's awesome.
Exactly.
How do you mount that tag?
So this tag has 2 holes, and since it's mountable on metal, either you're going to usually rivet it with a rivet tool, or you can go ahead and screw it into the metal itself. But a lot of people will rivet it.
Okay, still fairly easy. Mm-hmm. Good. Let's move on. What's the second tag you brought us?
That's right. So let me go ahead and grab my other tool here. So I've got a screw. And
you're not going to drill through the tag though, right?
Well, I'm not going to drill through the tag, but this tag, it's also made for metal. But we have to remember that that's going to take a little bit of time, especially when you're drilling into, let's say, metal. If you have a means to do that, it takes some time. I'm just going to drill into wood right now. And so I got my screw and I'm drilling that down. So that tag is fastened. Now that's going to take longer to do if you're affixing to this to metal. And why that's important is time has become very important these days. So that last tag that I showed you, that had 2 holes. And so that's going to take a person a little bit longer to mount.
I see.
And if you're working with 1,000 or 2,000 tags, that time really adds up. So this tag is great because it's just 1 hole. And as soon as it's drilled, you're good to go. You don't have to spend a little bit of extra time. And like I said, that time's really important.
Right. 1 hole versus 2 holes. Excellent.
Exactly.
Good. So what's the third one you brought?
Sure. Actually, I'm sorry. I forgot to mention that tag. The last tag is IUC 76-34-M-FR2, if you want to look it up and see what I'm referring to. But this last hole, or this last tag that I brought with me, I'm going to show you real quick what that sounds like. I don't need a tool for this. I just need my hand. Now, I don't know if you heard that.
Oh, I think that sounds like you ripped off some type of a tape, some foil.
That's right. Yeah, this tag is just an adhesive tag. And the beautiful thing about this is that this is even easier to manage than the last tag I introduced, because it's become a trend recently to, again, focus on time. So again, if there's a couple thousand tags, we're finding that people setting up these systems and tagging a bunch of equipment really like the fact that they can just rip a tag off and stick it right to their asset. And so they're loving that.
So that's very, very quick, of course.
Well, it is. And it's great that it's not just a paper tag either, because, now we're making adhesive tags that are suitable for an industrial environment. So they're...
Yeah, that would actually be my next question. Many of our listeners are aware of really low cost paper tags that are like stickers, and they work. But this one is a bit more, right? It's of sufficiently high quality for industrial applications.
You got it. Yeah, it can get banged around a little bit. It can handle wet environments. much more than a paper tag can. So it's great that we're starting to see more tags come out like this. It's been a real favorite. And I can tell you, I stuck it onto this piece of wood that I have in front of me here, and I can hardly get it off. I mean, we're doing a great job, and this is just a favorite of customers right now.
Now, would you utilize a tag like that for what's known in the industry as an open loop application, where a tag is kind of used at the beginning, applied to a product, and then leaves the facility?
Well, absolutely. I mean, the open loop concept is fantastic because it can keep the costs down a lot of times, and these tags do have a lower cost. So sometimes you get worried because you're going to buy one tag and leave it on an item, and it's going to go around and around and around again in that system. And usually they don't want to waste tags if the tags cost too much. But if you can get an industrial tag that's a little bit cheaper, you don't have to worry about having that tag survive for a very long time. You can put it on the asset. It's going to survive as long as it needs to. And then you're okay if that tag gets thrown into the trash or just kind of stays with the asset out into the world.
Yeah, makes sense. All right, Mike, we're running out of time. And as always in this program, I'm asking you to come up with a short statement, 5 words or so. What should our listeners take away from this episode?
We have a tag for that. So whether it's...
We have a tag for that.
Absolutely. That's
awesome.
We have a tag for that. There are about 20 different ultra high frequency tags in our portfolio. That last one is the IUC 8223L50. If you just type that in with an asterisk afterwards, you'll see the exact one that I'm using, but go check it out on our website. A lot of great tags, and we'll always find a way to make your application work when it comes down to the tags.
Thank you very much, Mike. We have a tag for that. And with that, we'll leave the show. Thanks, everybody, for listening. And we'll be back soon. Bye-bye.
Take care. Thanks, Helga. Bye.
We hope you enjoyed this episode of Pepperl+Fuchs Plugged In. Please subscribe to our channel and never miss hearing about the latest innovations in factory automation.